大家好，我是查理，这是 Most Charlie Aviation。欢迎来我的第一次课。This one will be about some basic maths in English, different temperatures and how to convert between the temperatures, and the speed of sound and how fast we fly in relation to that speed of sound. I'd just like to say that there will be some mathematics in this lesson. I'm not a maths teacher, and of course the maths is very basic. This lesson is not really about teaching you maths, it's more about helping you use maths in English with good pronunciation. Okay, let's get started. Alright, let's begin with adding and subtracting. We can say add or subtract if we're giving instructions. That's called the active voice. But we can also say plus, minus. We do that in the passive voice when we're asking questions or making statements. Let's do some examples. So let's say I tell you. Add 32 to 10. There you say add because it's an instruction. I tell you to do it. Add 32 to 10. So, there it is. It's going to be 42. And I tell you to do this. Subtract 32 from 10. And you do it. It's an instruction, a command, so it's active, so we use the words add and subtract. Alright, now we want to ask a question. Here we use the more passive way of doing it. What is 10 plus 32? What is 10 minus 32? So now we use the words plus and minus. And it's the same if we're making a statement. 42 is 10 plus 32. It's a statement. I'm telling you, 42 is 10 plus 32. And negative 22 is 10 minus 32. Alright? So you're making instructions. Again, use add, subtract. Asking questions, making a statement, plus, minus. Now, let's look at multiplying and dividing in active and passive. Alright, so now we have multiply and divide. So like before, active, if we're giving an instruction, we say multiply or divide. By something. So 9 by 5 or 5 by 9. In the passive, so if we're asking questions or statements, it's multiplied or divided. Something multiplied by something, something divided by something. And so with the statement, same thing as with the question, use the passive. 9 multiplied by 5 is 45. 5 divided by 9 is about 0.5. Okay, pronunciation. Active. Multiply. Multiply. Divide. Divide. Passive. Multiplied by, multiplied by, divided by, divided by. Now, practice, practice. What do we say here for an instruction? Yeah, multiply 2 by 4. Multiply 2 by 4. How about this question? What is 2 multiplied by 4? What is 2 multiplied by 4? How about this statement? 8 equals 2 multiplied by 4. 8 equals 2 multiplied by 4. With temperature and aviation, there are 3 main temperatures we deal with. Degrees Fahrenheit, or degrees F, is only really still used by the Americans. As you know, you'll be familiar with degrees Celsius, standardized by the general population of the world. And finally, for scientific purposes, there are kelvins, or degrees absolute. So let's just do a quick bit of pronunciation. Degrees Fahrenheit, degrees Fahrenheit. Degrees Celsius, degrees Celsius. Kelvins, kelvins. Degrees absolute. Now let's do some temperature conversion from degrees Celsius to Fahrenheit, and from Fahrenheit to degrees Celsius. First thing to remember, Fahrenheit is always a bigger number, a higher number than the Celsius. Okay. Celsius to Fahrenheit. You try. How would you say this? Alright, let's do it together. It's degrees Celsius multiplied by 9 divided by 5 plus 32. How about from Fahrenheit to Celsius? How would you say that? Let's do it together. It is degrees Fahrenheit minus 32 multiplied by 5 divided by 9. So there's your conversion. Okay, let's do some examples. What is 18 degrees Celsius in Fahrenheit? Better get the calculator. Alright, here it is, Xiaolan. I like Xiaolan. Let's do it. So 18 degrees Celsius in Fahrenheit. So 18 multiplied by 9 divided by 5 plus 32 equals sorry. Alright, 64. 64, okay. 18 degrees Celsius is 64 degrees Fahrenheit. Alright. Okay, next example. What is 10 degrees Fahrenheit in degrees Celsius? Work it out. So, first of all, it is 10 degrees Fahrenheit minus 32. So that's 22, multiplied by 5 divided by 9. So negative 22 multiplied by 5 divided by 9. Okay, so the answer is negative 12. Negative 12. Now, how would you tell me what to do with instructions? Have a go. Charlie, first, subtract 32 from the Fahrenheit, and then multiply that by 5 divided by 9. And there's your answer. Let's look at Kelvin. 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 So you can see that 0 degrees Celsius is plus 273 Kelvin. But we go down 0 Kelvin, which is absolute zero, the coldest possible, is negative 273 degrees Celsius. So if you change, you go up or down by 1 degree Celsius, you also go up or down by 1 Kelvin. Okay? So if you go up from here, warmer, you increase the number of degrees Celsius, you simply go up from 273 Kelvin. So for example, what is 30 degrees Celsius in Kelvin? Well, you just add 30 to 273. So you get 303 Kelvin. Pretty easy, right? How about negative 40 degrees Celsius in Kelvin? Yeah, you must subtract 40 from 273. 6, 5, 4, 3. Yeah, so you get 233 Kelvin, 233 Kelvin. All right, are you ready? 60 degrees Fahrenheit to kelvins. First thing you must do, convert to degrees Celsius. So 60 minus 32 is 28. Then you must multiply that 28 by 5 divided by 9, and that's 16 degrees Celsius. So 16 degrees Celsius is above zero, so you add that to 273. 289 kelvins. There it is. Alright, let's talk about the local speed of sound, which means how fast sound travels through the air where you are. Now, what speed do we use in aviation? Well, the most popular is knots, which means nautical miles per hour. Now, 1 nautical mile equals 1.852 kilometers. Now, a useful thing on the calculator is 852 are in a vertical line like this. So you can just remember 1.852. So 60 kilometers an hour is how many knots? Well, we just divide 60 by 1.852 and we get the answer 32 knots. Now, the speed of sound changes depending on different things like air density and temperature. Today we're going to focus on temperature. Okay, so you can see that the local speed of sound, local means where you are, is 38.94 multiplied by the square root of the temperature where you are in Kelvin. Remember, in Kelvin. Alright. Okay, let's pronounce square root. Square root. Square root. Okay, let's do an example. The temperature where you are is 15 degrees Celsius. What is the local speed of sound? It is 38.94 multiplied by the square root of the temperature in Kelvin. So 273 plus 15 is 288. So multiplied by the square root of 288 equals 661 knots. What would this be in kilometers per hour? Well, you would multiply this by 1.852. There it is. Here's another one. Okay, this time the temperature is lower. Let's work this out. Local speed of sound equals 38.94 multiplied by the square root of 268. So this is Kelvin. Remember, 273 minus 5 is 268. And the answer is 638 knots. So look, it's slower, it's a slower speed. So if the temperature is lower than normal, because we call 15 degrees Celsius normal, the local speed of sound will also be less. Remember that. Alright, 你们好吗？我脑子太累了。Okay, never mind. Let's talk about the Mach number. The Mach number is very simple, actually. It's just your true airspeed, so how fast your aircraft is flying through the air, over the local speed of sound. So the Mach number is a decimal fraction of your airspeed to the local speed of sound. So, if your true airspeed was 661 knots and the local speed of sound was 661 knots, what would your Mach number be? It would be 1, just 1. And what if the local speed of sound was 660 knots and your true airspeed was 330 knots? What would the Mach number be? .5. Mach 0.5. Okay, a question. This aircraft, true airspeed 720 knots. The temperature there is 2 degrees Celsius. What's the Mach number of the aeroplane? See if you can work it out. Okay, ready? Let's have a look. First, work out the local speed of sound. So the local speed of sound, 38.94 multiplied by the square root of Kelvin. So 2 degrees Celsius is 275 Kelvin. So we have 646 knots, LSS. So our Mach number is the true airspeed over the local speed of sound. Our Mach number is Mach 1.1. So the aeroplane is flying at Mach 1.1. Alright everyone, last example. In this example, we have our temperature. It's in degrees Fahrenheit. And we're talking about a helicopter, okay? We're given the helicopter true airspeed, 200 knots. We're also given the helicopter rotor tip airspeed. Now, as you may know, these are the rotors. Okay, so this is a rotor, and this is the tip. It's the end of the rotor. Rotor tip. Rotor tip true air speed is 600 knots. So it's going round at 600 knots. What is the rotor tip Mach number? Lai, have a try. Alright, so how did you do? Let's have a look. Remember, first, local speed of sound. The problem is we have Fahrenheit. So change to Celsius. 27 minus 32 multiplied by 5 divided by 9 gives us -3 degrees Celsius. In Kelvin, 270 Kelvin. So our local speed of sound is 38.94 multiplied by the square root of 270, which gives us 640 knots local speed of sound. And our helicopter is flying along at a true airspeed of 200 knots. But the rotors are spinning round at 600 knots. So the rotor on this half, the advancing half, at this point has the speed of the helicopter and its own speed together. So 600 plus 200 is 800 knots. So the rotor tip Mach number is 800 over 640. So the rotor tip Mach number is 1.25. 1.25. So in this last example, the helicopter's rotor tip went faster than the speed of sound over part of its rotation. So the helicopter blade tip speed broke the sound barrier. So remember, if your Mach number is more than 1, you are breaking the sound barrier. And that can cause problems, aerodynamic problems. So even for helicopters, the Mach number is an important thing. This is one of the reasons why helicopters are limited in their top speed. They cannot fly faster than certain speeds. The Mach number of the blade tip is one of the main reasons. Okay, so thank you very much for joining me on this first lesson. I hope you've enjoyed it. If you have any suggestions or comments, please write something below in the comment section. Thank you. 下次见.